What is sleep?
Sleep is probably the single most effective thing you can do to reset your brain and body health. So that's a functional answer in terms of, what is sleep in terms of its benefits. Sleep as a process, though, is an incredibly complex physiological ballet. And if you were to recognize or see what happens to your brain and your body at night during sleep, you would be blown away. And the paradox is that most of us, and I would think this too, if I wasn't a sleep scientist, we go to bed, we lose consciousness for 7 to 9 hours, and then we sort of wake up in the morning and we generally feel better. And in some ways, that denies the physiological and biological beauty of sleep. So upstairs in your brain, when you're going through these different stages of sleep, the changes in brainwave activity are far more dramatic than those that we see when we're awake. And we can speak about deep sleep and what happens there. REM sleep is a fascinating time, which is another stage of sleep, often called dream sleep, which is rapid eye movement sleep. That stage of sleep, some parts of your brain are up to 30% more active than when you're awake. So again, it's kind of violating this idea that our mind is dormant and our body is just simply quiescent and resting. So I would happy to just sort of double click on either one of those and also what changes in the body as well. But it is an intense evolutionary adaptive benefit and system. That said, though, I would almost push back against an evolved system when we think about the question of sleep and what sleep is. Our assumption has always been that we evolved to sleep. And I've actually questioned that, and I have no way to get in a time capsule and go back and prove this, but what if we started off sleeping and it was from sleep that wakefulness emerged? Why do we assume that it's the other way around? And I think there's probably some really good evidence that sleep may have been the proto state, that it was the basic fundamental living state. And when we became awake, as it were, we always had to return to sleep. In some ways, at that point, sleep was the price that we paid for wakefulness. And that's another way of describing what sleep is. But again, I think it sort of denies the active state of sleep. It's not a passive state of sleep either. And then finally, you can say what is sleep across different species. And in us human beings and in all mammalian species and avian species as well, sleep is broadly separated into these two main types. And we've got non-rapid eye movement sleep on the one hand, and then we've got rapid eye movement sleep on the other. And we can speak about how they unfold across the night and their architecture, because it's not just intellectually interesting from the perspective of what sleep is. It's also practically impactful for our daily lives. And I'd love to sort of go down that route too, but you navigate, you tell me. I can.
Let's definitely go down that route. So you mentioned how active the brain is during certain phases of sleep. When I was coming up in science, REM sleep, rapid eye movement sleep, was referred to as paradoxical sleep. Yeah. Is that still a good way to think about it? Paradoxical because the brain is so active and yet we are essentially paralyzed, correct?
Yeah, it really is a paradox. And where that came from was simply the brainwave recordings. That if all I'm measuring about you is your brainwave activity, it's very difficult for me sitting outside of the sleep laboratory room to figure out, are you awake or are you in REM sleep? Because those two patterns of brain activity are so close to one another, you can't discriminate between them. Yet the paradox is that when you are awake, I go in there and you're sort of sitting up, you're clearly conscious and awake. But yet when you go into REM sleep, you are completely paralyzed. And that's one of I think that's part of the paradox. But the paradox really just comes down to two dramatically different conscious states. Yet brain activity is dramatically more similar than different. And the way I can figure out which of the two you are in is by measuring two other signals, the activity from your eyes and the activity from your muscles. So when we're awake, we will occasionally have these blinks and we'll have sort of saccades. But during REM sleep, you have these really bizarre horizontal shuttling eye movements that occur. And that's where the name comes from, rapid eye movement
Are
sleep.
they always horizontal?
Mostly they are horizontal.
That's interesting.
And that's one of the ways that we can differentiate them from other waking eye movement activity, because it's not always, it can be sometimes horizontal, but can also have diagonal and also vertical in that plane. But then the muscle activity is the real dead giveaway. Just before you enter REM sleep, your brainstem, which is where the dynamics of non-REM and REM are essentially played out and then expressed upstairs in the cortex and downstairs in the body. When we go into REM sleep, and just a few seconds before that happens, the brainstem sends a signal all the way down the spinal cord, and it communicates with what are called the alpha motor neurons in the spinal cord, which control the voluntary skeletal muscles. And it's a signal of paralysis. And when you go into dream sleep, you are locked into a physical incarceration of your own body.
Amazing.
Why would Mother Nature do such a thing? And it's in some ways very simple. The brain paralyzes the body so that the mind can dream safely. Because think about how quickly we would have all been popped out of the gene pool. If I think I'm one of the best skydivers who can just simply fly, and I've had sometimes those dreams too, and I get up on my apartment window and I leap out,
You're done.
You're done,
Yep.
So that's one of the that's part of the paradox of REM sleep, both its brain activity similarity, despite the behavioral state being so different, and this bizarre lockdown of the sort of brain of the body itself. Now, of course, the involuntary muscles, thankfully, aren't paralyzed. So you keep breathing, your heart keeps beating.
Is this why men have erections during REM sleep and women have vaginal lubrication during sleep?
That's one of the reasons. Part of the other reason, though, there is because of the autonomic activity. So there is a part of our nervous system called the autonomic nervous system, and it controls many of the automatic behaviors. And some of those are aspects of our reproductive facilities. During REM sleep, what we later discovered is that you go through these bizarre, what we call autonomic storms, which sounds dramatic, but it actually is when you measure them. That you'll go through periods where your heart rate decelerates and drops, and your blood pressure goes down, and then utterly randomly, your heart rate accelerates dramatically, and what we call the fight or flight branch of the autonomic nervous system, or the sympathetic nervous system, badly named because it's anything but sympathetic, it's very aggravating, that all of a sudden fires up, and then it shuts down again. And it's not in any regular way. And it's when you get those autonomic storms, you get very activated from a physiological perspective, that you can have these erections and you have vaginal discharge, etc.
But you're totally paralyzed.
But you are still paralyzed. Yeah. There are only two voluntary muscle groups that are spurred from the paralysis. Bizarre. One, your extraocular muscles, because if they were paralyzed, you wouldn't be able to have rapid eye movements. And the other that we later discovered was the inner ear muscle. And we've got no good understanding as to why those two muscle groups are spurred from the paralysis. It may have something to do with cranial nerve, but I don't think it's that. I think it's perhaps something more sensory related. Some people have argued that the reason the eyeballs are spurred from the paralysis is because if your eyeballs are left for long periods of time inactive, you may get things such as oxygen sort of issues in the aqueous or vitreous humor. And so the eyeballs have to keep
the
moving
drainage
in some way.
systems of the anterior eye are made to require movement. That's
Exactly.
why people
Yep.
with glaucoma have deficits in drainage through the anterior chamber. But there I'm speculating. I'm also speculating when I ask this. I would imagine that there are states in waking that also resemble slow wave sleep, or rather that there are states that slow wave sleep also resembles waking states. You've beautifully illustrated how REM sleep can mimic some of the more active brain states that we achieve in waking. What sort of waking state that I might have experienced or experience on a daily basis might look similar to slow wave sleep, non-REM sleep, if any?
It's a genius way of thinking about it. Turns the tables. I love it. We almost never see anything like the true ultra slow waves of deep non-REM sleep. So we spoke about these two stages, non-REM and REM. Non-REM is further subdivided into 4 separate stages, stages 1 through 4, increasing in their depth of sleep. So stages 3 and 4, that's what we typically call deep non-REM sleep. Stages 1 and 2, light
So maybe
non-REM.
take me through the arc of a night, just so that.
Yeah.
So I put my head down. Well, for you, what time do you normally go to sleep?
So I'm usually sort of around about a 10:30 p.m. guy, and usually I'll naturally wake up sort of a little bit before 7, sometimes before 6:45 or 7. I have an alarm set for 7:04, and 7:04 just because, why not be idiosyncratic? I don't know why we always set things on these hard numbers. So, yep. So when
so you go to sleep around 10:30. So
Yep.
using you as an example, because I imagine a number of people go to sleep at different times, but 10:30 is about when I go to sleep. 11 is for me, but so you go to sleep at 10:30. So for that first, let's say 3 hours of sleep, what does the architecture of that sleep look like as compared to the last 3 hours of your sleep before morning?
Yeah. So I should note that sort of, 10:30 to 7, that's just based on my chronotype and my preferential. It's different for different people. I'm not suggesting that that's the perfect sweet spot for humanity's sleep. It's just my
But I imagine
natural
most
sweet spot.
people probably go to sleep somewhere between 10 and p.m. and midnight. And
It's
most
somewhere
probably
between, like,
wake up
9 and
between
midnight.
5 a.m. and 7 a.m. or 5:30 and 7:30.
Yeah. At least if you look at sort of first world nations, that's a typical sleep profile. So when I first fall asleep, I'll go into the light stages of non-REM sleep, stages 1 and 2 of non-REM. And then I'll start to descend down into the deeper stages of non-REM sleep. So after about maybe 20 minutes, I'm starting to head down into stage 3 non-REM and then into stage 4 non-REM sleep. And as I'm starting to fall asleep, as I've cast off from the, usually with me, murky waters of wakefulness, and I'm in the shallows of sleep, stages 1 and 2, my heart rate starts to drop a little bit. And then my brainwave pattern activity starts to slow down. Normally, when I'm awake, it's going up and down maybe 20, 30, 40, 50 times a second. As I'm going into light non-REM sleep, it will slow down to maybe 15, 20, and then really starts to slow down to about sort of 10 or 8 cycles per second, 8 cycle waves per second. Then as I'm starting to move into stages 3 and 4 non-REM sleep, several remarkable things happen. All of a sudden, my heart rate really does start to drop. Oh, and I'll come back to temperature. I'm going to write temperature down because I always forget these things. Now I'm sadly in the foothills of middle age. So as I'm starting to go into those deeper stages of non-REM sleep, all of a sudden, hundreds of thousands of cells in my cortex all decide to fire together, and then they all go silent together. And it's this remarkable physiological coordination of the likes that we just don't see during any other brain state.
That's really interesting. Having recorded from the brains of animals and a little bit from humans, I don't think I've ever seen the entire cortex or even entire regions of cortex light up like that.
Yeah, it's stunning. It's almost like this beautiful sort of mantra chant, or this sort of, it's a slow inhale and then a meditative exhale. Inhale, exhale, and these waves are just enormous in their size.
And the body is capable of movement at this time. There is no paralysis.
There is no paralysis, but for the most part, muscle tone has also dropped significantly at that point. And then I will then stay there for about another 20 or 30 minutes. So now I'm maybe 60 or 70 minutes into my first sleep cycle. And then I'll start to rise back up into stage 2 non-REM sleep. And then after about 80 or so minutes, I'll pop up and I'll have a short REM sleep period. And then back down I go again, down into non-REM, up into REM. And you do that reliably, repeatedly, and I will be doing that, and I do that every 90 minutes. At least that's the average for most adults. It's different in different species. What changes, to your question, is the ratio of non-REM to REM within that 90-minute cycle as you move across the night. And what I mean by this is, in the first half of the night, the majority of those 90-minute cycles are comprised of lots of deep non-REM sleep. That's when I get my stage 3 and 4 of deep non-REM sleep. Once I push through to the second half of the night, now that seesaw balance changes, and instead the majority of those 90-minute cycles are comprised either of this lighter form of non-REM sleep, stage 2 non-REM sleep, and much more and increasingly more rapid eye movement sleep.